Welcome back. In the previous video I talked about the accuracy, or we evaluated the accuracy of the ensemble classifier that is composed of these three classifiers, and each of these classifiers has a percentage or an accuracy of 70%, right? And we proved mathematically that the accuracy of the ensemble classifier that is composed of these three classifiers is higher than 70%, and it's in fact 78.4%, right? Now, what I want to talk about in this video is how to increase this accuracy here. What if I want to get an accuracy that is, for example, 0.8 or 80%? Well, to increase the accuracy, we need to increase the number of classifiers. That is, instead of taking only 3 classifiers, I could take, for example, 100 classifiers, and this would imply that the accuracy of the ensemble classifier would increase. Now, intuitively we can understand that this would be the case, but why? How we can prove that mathematically, or what is the reason that when we increase the number of classifiers, the accuracy of the ensemble classifier increases? Well, this has to do with something that is called the law of large numbers in mathematics, the law of large numbers. And I will talk about what large numbers means in this context, but what I want to do is to consider that I have a given classifier that has, say, classifier that has an accuracy of, say, 60%, right? And what I want to do is to increase the number of these classifiers at each time, and for each time that I increase the number of classifiers, I want to measure the proportion of the right answer and plot a curve for that, and observe what happens when this number increases. So this is concretely what I'm talking about. Say that this axis here represents the number of classifiers, CI, I'm talking specifically about CI, which has an accuracy of 60%, right? And here, for each of these numbers, I will represent here the proportion of the right answer, right? Normally, this proportion normally should be 60%, but it turns out that this is not the case, and I will tell you why. If I plot that curve, this is what I would get. Say that this is 60%, and it's also useful in this context to represent 50%. I will tell you why. So this is a horizontal line that represents 50%, and this is another horizontal line that represents 60%. Now, if I do this experiment, this is what I would get. I would get something like that. Something that has a high variance, something like that. And as I increase the number of classifiers, this curve starts to stick around this accuracy, which is 60%. And in fact, when it reaches infinity, then it's exactly equal to 60%, right? And if I repeat this experiment, this is what I would get again. Let me just use another color. If we repeat this experiment, we would notice that we have the same behavior. We have a higher, variance when we have a low number of classifiers, but when we tend to get a high number of classifiers, then this proportion of right answers tend to be exactly equal to 60%. Now, what does this curve mean here? For example, in this situation, when we have a curve that is, so this is 50%, this is 50%, and every experiment that gave us a proportion that is smaller than 50% represents an error, And the reason is because the ensemble classifier takes the right answer based on the answer that has the highest number of votes. And here we have a number of votes that is smaller than 50%. Therefore, everything that is under 50% is actually the wrong answer. So everything that is here under this 50% horizontal line is actually, so this is the wrong answer. So this is the wrong answer or wrong prediction. But notice what happens when the number of classifiers increases. When the number of classifiers increases, the curve sticks on 60%. It's consistently higher than 50%, and this is the reason why the accuracy increases. And in fact, when the number of classifiers is close to infinity or tend to be infinity, this implies that the accuracy of the ensemble classifier is equal to 100%. That's it. And this is called the law of large numbers. This is why we have this term of large numbers. The large number here is associated with the number of classifiers. When we increase the number of classifiers, then we have higher chances of getting the right answer. Now, there is something important that I shall talk about here. This law of large numbers has actually two assumptions. The first assumption, or to get 100% accuracy, we have two assumptions, right? Assumptions. And the first assumption is that the number of classifiers is very high, and ideally it's equal or tend to be infinity. And the second and the most important assumption, this assumption here is really important in ensemble learning, and I will tell you why. The second assumption is that all classifiers are independent. What's the meaning of this? This means that all the classifiers, or the result given by a given classifier, is independent by the result given by another classifier, right? And this is unfortunately not the case in practice. And one of the reasons is that the classifiers used to do the classification, the classifiers used in the ensemble classifier, can be trained or are trained on the same data set or on the same samples. They have some common training samples, and this means that some wrong answers can be repeated just because they have similar training sets, and this means that they are not completely independent. And however, we have found a way around that to take advantage of this law of large number to create our ensemble classifier, and I will talk about some techniques to reduce the independency or the dependency between classifiers in the next videos.